Sir, HOD sir, shall we start, sir?
Yes, I'm ready, Doctor. Dr. Rajesh, I'm ready if anytime you want.
Yes, sir. Thank you, sir. Thank you, sir. We'll be having the confirmation from our HOD, sir.
Okay, okay.
Then we'll proceed, sir.
Sure, sure.
Yes, sir, please. Excuse me, sorry, sir. Because of network problem, I couldn't join. Now I will start, sir. Good
Okay.
afternoon to 1.5%. Good afternoon to 1.5% here. I welcome all the participants to this Phase 3 6-day short-term training program on nanotechnology and functional materials. Now, let me introduce our resource person, Dr. Saurav Goyal from one minute. Yes, from Cranfield University, UK. He has completed his doctoral degree from Heriot-Watt University, Scotland, in the year of 2013. He has published many papers, more than 380 papers in national and international journals. His citations are 1903 and index 25, I-10 index 34. He has scholarship, Best Supervisor Award in 2018 and was nominated for the Best Lecturer at QUB Belfast in very first year of his teaching career. We are very welcome you, sir. We are honored with your presence, sir. I request our resource person to continue with the session, sir.
Sure. Shall I begin or shall I wait?
Yes, sir. Sorry, sir. Please, sir. Please, sir.
Okay.
Please.
Okay. Thank you very much for that warm introduction, Dr. Rajesh and the team to organize this wonderful event. I'm going to share my screen and please let me know if you are then able to see the screen.
Yes, sir. Yes, sir.
So is it okay to view the screen? Can you see the screen?
Sir, we can able to see the screen, sir. Yes, sir. No problem, sir.
And am I audible okay as well?
It is loud and clear, sir. You can proceed, sir. Yes, sir.
Perfectly fine. Great.
Thank you.
So good afternoon to you all. It is a wonderful opportunity to interact with all the audience that are present in this wonderful STTP course supported and sponsored by AICTE in the South India part of Hyderabad. So I've not myself been there, so I just wish that COVID situation is getting better there. But I've just shared a video in case if you want to look at the recent advances of nanotechnology, which is the theme of this workshop. I think it's a very wonderful example to look into the thematic area of coronavirus. We have presented a lot of solutions in the paper, and thereafter this video came out, which I've shared in the chat box. So please feel free to look at that video also when you have time. So now, currently, I was requested to present something relevant to what we are doing here at Cranfield University, as well as London South Bank University, to discuss with the participants of the advances that are taking place in the UK. So accordingly, I have presented this slide or prepared this slide to look and to look forward to interact with you all in the next 1 hour or so. So first thing I wanted to look and share with you was these PhD opportunities. So those who may be interested to pursue their career abroad, especially in the UK at London South Bank University, there are a couple of funded PhD options that are available with myself and my colleagues. So if you or any friend of yours that you know is very talented and bright and would like to build their career in a PhD sort of stream in the UK, you are very welcome to apply for these PhD programs and PhD studies in the UK. And you can also have an informal discussion with me over the email. I will be happy to answer any of your queries. Right. So I will move to the agenda to begin with. What I want to really do today is I want to introduce, first of all, about myself. I want to take some time out of this presentation to give you a brief introduction and background to where I'm actually coming from in terms of my professional growth, and then some background to what our research laboratory is like and what kind of ambitions are we having in terms of conducting precision engineering research, and how do we empower this to be the 21st century enabler of nanotechnology, which is nothing but a technology that strives us to take forward in the realm of nano and sub-nano world. I would then be showing or presenting some case studies specific to the precision engineering examples, and to show that the precision engineering world is not just about making or achieving precision components at a very micro or nano scale, but having the ability to retain that precision over a larger and relatively longer length scale over a meter is what we mean by precision. So precision can be in the feature size, but not necessarily in the size of the component that we make. So this is how I'm going to organize my talk, and I hope I can show you a fair glimpse of what we are doing within the limited time that we have today. Now, one thing I should also note here is I'm very delighted to learn that the Indian government has launched this initiative of Vaibhav program, which is, I think, an excellent initiative to bring together global expertise in various fields of manufacturing and engineering in general, to allow a broader audience to promote indigenous manufacturing across India. So I just come to learn that I have been nominated to be one of these speakers on 12th October. So I think there could be a second opportunity to interact with the audience, that if some of you are available or going to be available in this one of the summit program on 12th of October. Now, this is my academic background. I finished my schooling from NCR region of Delhi, and thereafter I went on to do my bachelor's degree from northeastern part of India in mechanical engineering. And I also spent some time working for a construction company based in Chennai, which is Larsen and Toubro Limited. But I was destined to do my doctorate research since the time I achieved my bachelor's degree. So after spending about 3 years of time, I wrote a research proposal that brought me to Heriot-Watt University at Edinburgh in the UK to conduct a PhD study on a funded program. I was fortunate enough to complete my PhD in 2.5 years, and with about 15 journal publications, which led me to join as a faculty position directly within the UK in a Russell Group university called as Queen's University in Belfast. So I did not pursue postdoc, as I was not required to do it because I had substantial number of publications in my CV already. And I continued the academic journey. I moved on to Cranfield University, which is the global hub of precision engineering. But at the moment, I am actually holding 2 positions at the same time. I'm also a lecturer at Cranfield, but also I'm an associate professor at London South Bank University, which is in central London next to London Eye. So this is how my career is evolving. And in this period of time, I have remained thoroughly engaged with the manufacturing experts across India, right from Mumbai to till Guwahati. So what you're seeing there is that I have been frequently in touch with Professor V.K. Jain, who has invited me on many occasions in the AICTE sponsored micro manufacturing workshop that used to take place at IIT Kanpur. And I have also been honored by conducting a Gyan course at IIT Guwahati. So all of these avenues have kept me well in touch with wider audiences and other delegates and academics to be involved
Sir,
with.
Gaurav sir, excuse me, sir.
Yep.
Actually, someone has presented their screen, sir. And now it's okay, sir. Please, sir.
Okay. So, yeah, so basically I have remained in touch with Indian academia and other people to keep myself informed and them informed of the advances that are taking and shaping in manufacturing, especially in precision manufacturing and the world of nanotechnology. Now, based on those interactions, we have been able to produce some very, very nice papers. So these are some examples of those papers where you can easily see that we have worked together with a couple of IITs that included IIT Kanpur, IIT Bombay, IIT Guwahati, and more recently we have published 2 papers with CSIO Chandigarh Lab, who are having a lot of resources in terms of conducting a lot of machining trials and polishing and grinding and these kind of nanotechnologically controlled sample preparation trials. So that is a glimpse of my interactions with India. Now, coming back to the kind of resources we have at Cranfield University. So this slide basically shows a range of facilities we have in the micro manufacturing suite. So what you're seeing there is this is a 5-axis milling machine from Morisiki. Then what you're seeing here is an ultra precision single point diamond turning machine from Mo Nanotechnology. What you're then seeing is a locksum machine, which is capable of doing micro milling and single point diamond turning. There is then a Liège coordinate measurement machine, which is made from Swiss company. There's a micro milling machine from Kern, which is a German-based company. So all these 4 machines are largely catering to machining activities, and they are pretty much general purpose machining tools. But the 3 machines that are shown here, these 3 machines, they are very unique because they were purpose built for preparation of some of the prototype mirrors for the European extremely large telescope that I'm going to discuss in the later part of the case study today. The objective of this telescope mirror was to mount an assembly of more than 45-meter diameter with less than a micron form error. So you can imagine the kind of precision we are talking about. 1 micron flatness over 45 meter. So that was unprecedented, and this is why these grinding, polishing, and plasma figuring machine were purpose built to create a sequential micro machining chain, which I'm going to discuss today as well. Then there's an obvious question of the kind of products that these machines can produce. So these are the range of products these machines have been producing. So ranging from this small component of a mirror, which has 21 segments of mirror, and it's a small component that is going to be going to mid-infrared telescope in James Webb Space version of the telescope. This small component to tell this big, large-scale mirrors that you can see here. They are all produced by such kind of machining facilities. So what we are seeing here basically is a video of a copper drum that is being machined on a drum lathe to be able to produce 25 micron grating patterns with very, very fine accuracies. What you're then seeing here is a standard apparatus that has been machined for advancing the state of nanotechnology. So this is the only apparatus in the world which is basically a triaxial ellipsoid profile. So the region of argument here is if you have this kind of hemispherical cavity, one mounted on the other, then when you fill an argon gas of a known volume and pass the velocity of sound, you can correlate this to the molecular static energy within the apparatus. And that gives you a most precise experimental value of Boltzmann constant ever known. This has then allowed this Boltzmann sphere to be standardized in the SI units. This is the most latest advancement of ultra precision engineering or nanotechnology to make this component with very extreme fine accuracy to experimentally determine the most uncertain value of Boltzmann constant, and hence the reason it is being called as Boltzmann sphere by the National Physical Laboratory. What you're then seeing are some of the other samples that are machined by a couple of our masters and PhD students. So these are various components: radial sinusoid, silicon wafer machine with a very smooth optical finish in a perfectly ductile regime. And then you are seeing another component made in a copper sample. So these are some of the unique products that we have created from these labs. Now, the next thing is I want to also share with you what I am doing in terms of my own research. So this slide basically shows a classification of activities that I am at the moment performing to inform these various research endeavors. So you can see that I classify my research across a breadth of machining, nanotechnology, and measurement plus modeling activities. So in order to deliver an ambitious precision engineering product, you have to completely, thoroughly understand the process informed by the basic sciences. And once you have understood the basic sciences of the process, you then carry out the necessary engineering to master the art of making the product. So starting from multi-skill modeling, which entails the art of performing FEA simulation and MD simulation, I go all the way to material prediction. So this is an example of a finite element simulation of cutting a silicon substrate. So I'll just replay it in case if you will not have seen it. So when we are cutting a silicon substrate, which is a hard and brittle material, you can see a lot of cracking here. Now, this is the limitation of finite element analysis, that we cannot go beyond what FE allows us to see. So if you want to understand the cracking behavior more precisely, we have to switch to the so-called molecular dynamic simulation, which is capable of showing a very precise material-oriented details of what happens in the vicinity of a crack. So here you see the silicon was being cut, the atoms started to flow, a crack originated ahead of the crack tooltip, and this crack continued to grow while this is being pressed by the flowing phase of amorphous silicon material, and that's how the journey of crack evolves. So depending on the extent of the depth of crack, it can either self-heal or it can continue to remain whatsoever is the fate that governs the subsurface integrity of a machine component, which is what importantly matters in terms of governing the life of the component. Now, why these simulations are extremely essential and necessary is because we want to be more deterministic in our advent of precision manufacturing of products, whether we are taking help of subtractive manufacturing or whether we are depositing the materials. In both cases, we have to understand materials behavior. So here is an example of a subtractive manufacturing called as diamond turning, which is an important and vital tool for nanotechnology. Here, what you see is a component is being machined by a single crystal diamond tool, such that we are able to achieve atomic scale fine material removal in almost any shape, whether it is circularly axisymmetric or whether it is non-axisymmetric. So this is the beauty of single point diamond turning, that it allows us to shape components to achieve near atomic scale roughness, either with the inclusion or exclusion of tool servos. So this is the CNC code generation taking place in real time. In parallel to this subtractive manufacturing, there could be other kind of processes such as this additive sort of manufacturing, which is called as roll-to-roll manufacturing. So what you see here is a diffraction pattern which was being rolled on a polymer film with a very fine accuracy.
Sir,
So all these
Saurav, sir.
Yeah.
A small interruption, sir. Sir, can you just click on that hide icon, sir, so that it will be visible better, sir?
Oh, sorry.
Yeah. Thank you,
Oh.
sir. Sorry for the disturbance.
So are you able to see the videos when I'm playing those?
Yes, sir. It is visible, sir. Yeah.
Okay. Great. Okay. So here is an example. Again, I will show about the roll-to-roll manufacturing process. Here is the small hologram pattern that is being printed on a polymer film. So this is a PET polymer film, which can be printed directly